Welcome to Review and Preview Problems 8-123 to 8-129 in the CCG book. Question 8-123 says, the City of Denver wants you to help build a dog park. The design of the park is a rectangle with two semicircle ends. A semicircle is half of a circle. The entire park needs to be covered with grass. If grass is sold by the square foot, how much grass should you order? So this means we want to find the area of our park. We know that we are working with two semicircles which create an entire circle. They told us that that radius is 30 feet, and they told us that the length of our rectangle is 55 feet. So we know that this little piece here is also 30 feet. So to find the area of this portion of our dog park, we would do 60 times 55, which would give us 3,300 feet squared. Looking at my circle, the area of a circle is found by doing pi r squared. When I multiply, or when I square 30, I get 900 pi. So when I add 900 pi plus 3,300, I get a total of 6,127.4 feet square. So remember, don't type in your pi until the very end. So question 2 says the park also needs a fence for its perimeter. A sturdy chain link fence costs about $8 per foot. How much will the fence for the entire park cost? Well, the first thing we need to find is the perimeter of what we need. So to find perimeter of a rectangle, we just add up both of the sides. So the rectangle is going to be 110 feet. To find the perimeter of a circle, it is actually called the circumference, and it's 2 pi times the radius. So if we multiply our radius by 2, 2 times 30 gives us 60 pi. So when we take 60 pi and add it to 110 feet, we get approximately 298.5 feet. It then told us that it was $8 per foot. So if we multiply that dollar amount by $8, the entire cost would be $2,387.96. So we could say that it is approximately $2,388. Letter C says the local design board has rejected the plan because it was too small. Big dogs need lots of room to run, the president of the board said. Therefore, you need to increase the size of the park with a linear scale factor of 2. What is the area of the new design? What is the perimeter of the new design? So remember, perimeter was talking about one dimension. So if they told us our linear square factor is 2, we could take the perimeter that we found above. So the perimeter of our park was 298.5, and we could simply multiply that by our scale factor of 2, which would tell us that the perimeter is twice as long, so 597 units. Our area, however, is talking about a two-dimensional, so we need to take into consideration both dimensions that we are talking about. So we would take that linear square scale factor and square it, so we would get 4. Then we would take the area of what we found above, 6,127.4 feet squared, multiply that by 4, and we would get 24,000 509.6 feet squared for our new area. 8-124. This problem is a checkpoint for angle relationships and geometric figures. It will be referred to as checkpoint 8. For each diagram, solve for the variable and name the relationship used. So looking at letter A, I know that these two angles are supplementary angles and they equal 180 degrees when they're added together. So 4x minus 3 plus 3x plus 1 is equal to 180. So 7x minus 2 equals 180. Use my inverse operations. 7x is equal to 182. Divide by 7, and I get x is equal to 26 degrees. Looking at letter B, I have two parallel lines that is being cut by a transversal. So I know that these angles are congruent because they're vertical angles. These angles are congruent because they're alternate interior angles. And these angles are congruent because they're vertical angles. I also know that 5x plus 6 is equal to 2x plus 21 because they are alternate angles. I can use my inverse operations. I get 3x is equal to 15. Divide by 3, I get x is equal to 5 degrees. Looking at letter C, I see that I am looking at a triangle, and I know that all the angles in a triangle add up to 180 degrees because of the triangle sum theorem. So I can set 4x plus 28 plus x plus 19 plus 3x plus 13 equal to 180. I need to combine my like terms, so I have 8x's plus 60 equals 180. Inverse operations, I get 8x is equal to 120. When I divide 120 by 8, I get x is equal to 15 degrees. Looking at letter D, I know that these two angles right here are supplementary angles. So I could say that these two angles equal 180 degrees. I also learned that my exterior angle is equal to my remote interior angles, which is the one not connected to it. So I can actually set 4x minus 10 equal to 40 plus 90. So when I solve using my inverse operations, I get 4x is equal to 140. Divide by 4, I get x is equal to 35 degrees. 8-125 says line segment BE is the mid-segment of triangle ACD. So if we know that it is the mid-segment, we know that this piece, CB, is equal to BA, which means this would also be 7. We know that AE is equal to ED, which would make this side 6 as well. This would also tell us that line segment CD is 22 inches because it is double of what line segment BE is. So when we find the perimeter, we would add 22 plus 14 plus 12, which would give us 48 centimeters. If the area of triangle ABE is 19 centimeters squared, what is the area of triangle ACD? Well, when we are talking about area and we are talking about a zoom factor, we know that our perimeter is times 2, so we would take that perimeter and square it, which would give us a 4. So if we know the area of ABE is 19 centimeters squared, we can multiply that by our zoom factor of 4 and get 76 centimeters squared. 8-126 says Christy has tied a string that is 24 centimeters long into a closed loop like the one to the right. She decided to form an equilateral triangle with her string. What is the area of the triangle? So an equilateral triangle, remember, means all of our sides are the same. If we know the string was 24 centimeters long, we could take 24 and divide that by 3, which would tell us that each side of our triangle is 8 centimeters. Then to find the area, if we know that each side of our triangle is 8 centimeters, we could create a right triangle, which would make this side 4. We could use our Pythagorean theorem to determine our other side. So 8 squared is equal to 4 squared plus our height squared. So we would want to subtract 16 from 64, which gives us 48. Take the square root of 48, which is approximately 6.93. To find the area, we take our base times our height divided by 2. So 8 times 6.93 divided by 2 would tell us that the area of the triangle would be about 27.71 square feet. She then forms a square with the same loop of strings. What is the area of the square? So if we form a square and we take 24 and divide it by 4 this time, our sides would be 6. The area of the square would be 6 times 6, which would give us 36 square feet. This is actually a greater area than what we originally created with the triangle above, so it's more. If she forms a regular hexagon with her string, what would its area be? Compare this area with the areas of the square in the equilateral triangle from above. So if we create a regular hexagon, a hexagon contains 6 sides. So if we take 24 and divide it by 6, it would give us a base of 4. We could find our central angle by doing 360 divided by 6, which would give us a central angle of 60. If we drew this triangle out and made it a right triangle, we would be working with a base of 2, an angle of 30. We could find the height of our triangle using the tangent of 30 degrees equals 2 over our adjacent side, which this time we represented by height. Use your inverse operations. So h would equal 2 divided by the tangent of 30, which equals 3.46. Multiply the base of our triangle, which is 4, times 3.46 divided by 2 tells us that the area of just this triangle right here would be 6.92. We have 6 of them in our hexagon, so we need to times this by 6, which would give us the area of 41.52 square feet. So again, we gained more sides to our shape. We had 2 additional sides, and this time our area was also more at 41.52 square units. So it is greater than both the equilateral triangle and the square. Letter D says, what shape should Christy form to enclose the greatest area? Well, if we continue to increase our shapes, our polygons, to larger and larger areas, the larger and larger amounts of sides, the area will continue to grow. So if we create a circle with our string, it will give us the largest area. 8-127, 3 spinners are shown below. If each spinner is randomly spun, and if spinners number 2 and number 3 are equally divided, find the following probabilities. So the probability of spinning an A is 3/4 chance. The probability of spinning a C is 1/2. The probability of spinning an E is 1/3. When we multiply all of those together, we get 1/8, which is 0.125 chance, or 1/8 probability to spin those numbers. P says, what is the probability of spinning at least one vowel? So of spinning a vowel in the first one, we have a 3/4 chance. We have a 0 out of 4 chance, out of 2 chance to spin a vowel in the second spinner, and in the third spinner we have a 1 out of 3 chance. So if we use an area model instead to determine our probability of spinning a vowel, so because we have 3 spinners, we couldn't use that area model, but we can use a tree diagram. So spinner 1, we have the chance of spinning an A or a B. Then when we spin spinner 2, we have the chance of spinning a C or a D, depending upon what we originally got. And then when we spin spinner 3, we can get an E, an F, or a G. So we can see that from our tree diagram, we have a 5-6% chance of getting at least one vowel. 8-128 says the isoprometric theorem states that of all closed figures on a flat surface with the same perimeter, the circle has the greatest area. Use this fact to answer the questions below. A. What is the greatest area that can be enclosed by a loop of string that is 24 centimeters long? So if our circumference is equal to 24, circumference equals 2 pi r. So we'll set 24 equal to 2 pi r, divide by 2 pi, and we get a radius of 37.7 centimeters. We then want to know what the greatest area could be for that. So area is equal to pi r squared. So we take that radius, we square it, 37.7 squared, multiply that by pi, and we would get the greatest area of a circle we could have is approximately. So make sure this doesn't make sense. Make sure you check your math. When we divide 24 by 2 pi, we actually get an area, sorry about that, of 3.819, so, or a radius, excuse me, of 3.82. When we plug that into our area formula, which is pi r squared, the area is equal to pi times 3.82 squared, which gives us an area of approximately 45.84 centimeters squared. What is the greatest area that can be enclosed by a loop of string that is 18 pi centimeters long? So if our circumference, which is 2 pi r, is equal to 18 pi, we divide by our 2 pi, so we get 9 is equal to our radius. The area is equal to pi r squared. 9 squared is 81. So our area is about 81 pi, which is equivalent to approximately 254.47 centimeters squared. 8-129 is a multiple choice problem. The diagram below is not drawn to scale. If triangle ABC is similar to triangle KLM, find line segment KM. So it is not drawn to scale, but I can put my triangles, set them up a little nicer so I can see that 18 and 6 look to be a similar side. So if I multiplied by 3 and I was looking for line segment KM, which would be here, 9 times 3 would be 27, which is none of these choices.